Solid-state batteries are generating significant excitement in the energy storage field, hailed as the next big leap forward for both electric vehicles, EVs, and grid storage systems. They promise substantial improvements over traditional lithium-ion batteries, offering higher energy density, greater safety, faster charging times, and longer lifespans. But as with any emerging technology, they are not without challenges. High costs, manufacturing hurdles, and still evolving environmental impacts mean that solid-state batteries have a long way to go before they can replace the batteries we rely on today. This video will break down the key reasons why solid-state batteries matter, what challenges lie ahead, and how they stack up against both current technologies and other eco-friendly alternatives. Just a friendly reminder to hit the like button and subscribe if you enjoy this video. It costs you nothing, and I do appreciate it. Thank you. Let's get back to the video. One of the most compelling reasons why solid-state batteries are so significant is their potential to store more energy in a smaller, lighter package. Traditional lithium-ion batteries have a good energy density, but solid-state designs take this to the next level. This means that electric vehicles could drive much further on a single charge, and portable devices could last longer without requiring larger, heavier batteries. The improved energy density is a critical factor in making EVs more practical for everyday use, helping to alleviate range anxiety and extending the overall usability of these vehicles. Safety is a major concern with current lithium-ion batteries. These batteries use liquid electrolytes, which are flammable and can pose a significant fire risk if the battery is damaged or improperly charged. In contrast, solid-state batteries use solid electrolytes, which are non-flammable. This dramatic safety improvement could significantly reduce the risk of fires or explosions, particularly in high-stress environments like electric vehicles, where battery failure can be catastrophic. The solid design also prevents issues like thermal runaway, a dangerous condition where a battery can overheat and catch fire. Another area where solid-state batteries outperform their lithium-ion counterparts is charging speed. Solid-state batteries have the potential to be recharged in a fraction of the time it takes a typical lithium-ion battery. With advancements, full recharges could be completed in 10 to 20 minutes. For electric vehicles, this would make charging as quick and convenient as filling up a tank of gas. This reduces downtime and makes EVs much more user-friendly for a broad range of drivers. Solid-state batteries are also expected to last much longer than traditional lithium-ion batteries. One of the main reasons for this increased longevity is their ability to withstand more charge and discharge cycles without significant degradation. Over time, lithium-ion batteries lose capacity due to chemical reactions that happen within the battery as it goes through cycles of charging and discharging. Solid-state batteries, however, are less prone to these issues, which means they could have a longer operational life, reducing the need for frequent replacements and the associated costs. Beyond their technical advantages, solid-state batteries also have the potential to be more environmentally friendly. They are made with fewer hazardous chemicals, such as the flammable liquids used in lithium-ion designs, and they could reduce overall emissions and material waste in production. Studies have shown that solid-state batteries may reduce their carbon footprint by as much as 39% compared to conventional lithium-ion systems, primarily due to their higher energy density and more efficient use of raw materials. These improvements could help make the transition to electric vehicles and renewable energy storage more sustainable in the long run. Despite the promise, solid-state batteries are not without their challenges. One of the major barriers to the widespread adoption of solid-state batteries is their high cost. Currently, the price of manufacturing solid-state batteries is significantly higher than that of lithium-ion batteries, with costs ranging from $300 to $500 per kilowatt-hour. This is 2 to 3 times more expensive than lithium-ion batteries, which typically cost between $100 to $150 per kilowatt-hour. While solid-state batteries offer many performance benefits, their high cost makes them less appealing for consumers and manufacturers at this stage. Lead-acid batteries, which are even cheaper, may seem like a good alternative, but they are much heavier and have significantly lower energy density. The production of solid-state batteries is also more complex than lithium-ion technology. Creating solid electrolytes that are both stable and efficient requires precise manufacturing techniques. Engineers must ensure that these solid materials are defect-free and possess the necessary properties for consistent performance. Additionally, solid-state batteries require more specialized production methods because the materials used are often brittle. The process of scaling up to mass production introduces challenges like ensuring the purity of the materials and avoiding imperfections that could compromise the battery's effectiveness. Despite their potential, solid-state batteries still have some performance weaknesses that need to be addressed. One of the biggest issues is the potential for crack formation in the solid electrolyte material, which could reduce the battery's ability to charge and discharge effectively. Other concerns include high interfacial resistance, which reduces charging efficiency, and poor performance in extreme temperatures. Additionally, there is still a risk of lithium dendrite formation, tiny, needle-like structures that grow inside the battery and can cause short circuits if not properly managed. Solid-state batteries are not yet available on a large scale. Most automakers and battery manufacturers are still in the research and development phase, working to refine the technology and overcome these hurdles. As of now, solid-state batteries are mostly seen in pilot projects, and it may take several more years before they are available for commercial use at a competitive price. Here's a quick comparison of solid-state batteries with other types of batteries in terms of cost, energy density, and weight. Lead-acid batteries are the least expensive, ranging from $50 to $120 per kilowatt-hour, but they have a low specific energy of 30 to 40 watt-hours per kilogram and are the heaviest option. Lithium-ion batteries, which cost between $100 to $150 per kilowatt-hour, offer a much higher specific energy of 160 to 300 watt-hours per kilogram, making them lighter than lead-acid batteries. Solid-state batteries, though currently expensive at $300 to $500 per kilowatt-hour, are the lightest, offering a specific energy of 350 to 500 watt-hours per kilogram today. With future models reaching up to 800 watt-hours per kilogram, they can be up to 40% lighter than lithium-ion for the same output. One of the standout features of solid-state batteries is that they use fewer hazardous materials. Traditional lithium-ion batteries rely on flammable liquid electrolytes, but solid-state batteries use solid materials that are not only safer, but also potentially more sustainable to produce. As solid-state technology evolves, it could reduce the overall chemical usage and lower carbon emissions from production. Solid-state batteries are expected to last longer than their lithium-ion counterparts, meaning fewer batteries will need to be produced and discarded. This could reduce the total number of batteries required for EVs, electronics, and grid storage over time. When it comes to recycling, solid-state batteries also show promise. Some designs use less cobalt and nickel, which are difficult to recycle and have significant environmental costs. This could make solid-state batteries more recyclable and less harmful to the environment over their lifespan. However, there are still environmental concerns. Solid-state batteries still require lithium, often more than current lithium-ion batteries, and lithium extraction can have a significant ecological impact. New extraction methods such as geothermal lithium mining could make this process more sustainable, but this technology is still in development. The solid electrolytes in solid-state batteries make them safer to handle, especially when it comes to disposal. Unlike lead-acid and some lithium-ion batteries, solid-state designs are less likely to cause harmful environmental contamination through leaks or improper disposal. While solid-state batteries show great promise, other technologies are also being developed to make energy storage more sustainable. Sodium-ion batteries use abundant sodium instead of lithium, making them cheaper and more sustainable, though they currently have lower energy density. Flow batteries, such as vanadium, iron, and zinc. These batteries are excellent for stationary storage and are highly recyclable, but they are too heavy for use in EVs. Lithium iron phosphate, or LFP, is a safer, non-toxic alternative to traditional lithium-ion batteries, already widely used in EVs. Lithium-sulfur offers high energy density and lower toxicity, but is currently limited by durability issues. Aqueous/metal oxide systems are chemistries, such as manganese-based water batteries, that show promise for being environmentally safer and more affordable, though they face challenges in scalability. In summary, solid-state batteries represent an exciting step forward in energy storage technology. They promise to be safer, longer-lasting, and more energy-efficient than current lithium-ion batteries. However, their adoption is hindered by high costs, manufacturing challenges, and environmental concerns related to lithium mining. Despite these hurdles, solid-state batteries hold significant promise for the future, particularly as a safer and more sustainable solution for electric vehicles and grid storage. Moreover, emerging technologies like sodium-ion, flow, and lithium-sulfur batteries offer additional avenues for more sustainable energy storage. The road ahead for energy storage technologies is not just about perfecting solid-state batteries, but also about building a diverse, eco-friendly energy future. So what do you think? Leave me a comment and check out some of my other videos. Don't forget to hit the like button and please subscribe. Thanks for watching, and we will see you at the next one.